Hello, welcome to this new issue of InSite-Bytes, reviewing the tools available in InSite for the picking of phase arrival in waveforms for our recorded seismic and microseismic events. So, here we have the workflow, the typical workflow for the processing of seismic events, and we can see right in the middle of it is the picking of our waveforms, the identification of phase arrivals, specifically the P wave and the S waves, which are an essential step in the location of our events and in any further interpretation. InSite has tools for an automatic picking of both phases, both the P and the S wave phases, as well as the capability for manual adjusting or manual picking these arrivals. One of the algorithms used for the automatic picking is using a double window, basically a customizable back and front window that goes through the traces of all instruments and identifies an arrival, the P wave or S wave arrival, by comparing the amplitudes in the trace sections contained in each of the windows. We can see here, and we will see that in InSite, what is called the picking function, that is the value of the ratio in between the amplitude, the total amplitude contained in the front window and the back window. The peaks, or the maximum in this function, are used as the picking for the detection of the arrival. So let's have a look at InSite. And here we have projects with events that have already been imported, processed and located. It corresponds to the hydraulic fracturing treatment of a vertical well monitored using a string of geophones deployed down another vertical borehole located approximately around 400 meters from the treatment well. So let's examine our waveforms, and you can see in this view, this is called the move-out view, the arrivals of the P wave followed by the arrival of the S wave. And we can see they follow a pattern, it's called the move-out, which is typical for this type of vertical seismic arrays. So, if we go to processing settings, we have a series of tabs. The first tab we need to look at if we want to configure the way auto picking works in InSite is the auto picking tab. And here we have the options for using either the amplitude of the root mean square waveform, the amplitude of an envelope fitted to our waveforms, or using the autocorrelation, the Akaike autocorrelation method. We're going to have a look at the simplest option for us. It's a very good data set, so we don't need to use any advanced tools. And we need to make sure that we have selected the capability for picking, auto-picking the P wave and the S wave. The most important parameters that we need to check and we can customize are the length of the back and the front windows. Length here is expressed as sample points, so depending on the sampling rates of our acquisition system, this can translate into time. We set the back and the front. The front, in theory, is looking at the signal, and the back is looking at the noise part of our trace. So comparing the amplitudes in both, if we go above a certain threshold, in this case we've set it to 1, it's a very good data set, InSite will pick an arrival. There are options as well, as you can see here, to establish what will be the maximum and the minimum time in between both the P and the S wave. If we think there should be a minimum separation or a maximum separation in between the arrivals of the P and the S wave. We also have the option to perform first search for the S wave and then for the P wave. By default, InSite will search first for the P wave and then we'll try and find the S wave. In many cases, the P wave is highly attenuated and it's easier to find first this S wave and then go back and try and detect the P wave from it. And similar settings apply to the S wave. You can see here the length of both windows and the threshold. So if we click here, we can check how auto peak works. For the P wave, you can see it's been a reasonable peak, and for the S wave after it. We can then manually adjust each of these peaks if we think it has not picked the onset of our trace, our phase. We can also right click and add a new peak if we want, if it has not been detected. And we can, if we are not happy with the results from the picking, we can cancel each of them independently and try again with new settings. This is recommended to check on a sample event before we run the auto processing through all our catalog of waveforms. So let's try and change our settings and see if we can get a better peak. In this case, let's push it and let's make a shorter back window and let's see the effect of that on our data. Yeah, we can see this is going the wrong way. We've made both windows equal, set our threshold to 1, so effectively it's detected the first peak or the first bump in our trace as the arrival of the P wave. So this is not a good setting, so let's go back, make this slightly larger. Let's go as we had, 30. Oh, still not enough. So let's iterate a bit more and see if we're getting back a good result. As we are. And something for the S wave. We can go into the channel view of each of the traces. So if we double click on, go to this. Go to one of the channels, we can see a display of our picking function with the settings that we have set in our processing settings. And we can see it's a very well defined function, so it's easy to detect the arrival of the P wave, and similarly for the S wave. Okay, so let's go back to our waveform moveout, and we're going to have a look at a different tool that's also available in InSite, which is the draw arrival. So we can draw the arrival of the P wave and the S wave. And what does it mean? If we select this, we can drag by left clicking. We can drag the mouse across the traces for all of our array, all of our instruments, and InSite will pick the first arrival that it finds around that line. So it's a way of guiding our picking. Oh, we can do exactly the same thing for our S wave arrival. So you can see, yeah, it's picked some tools. It didn't detect the first one, probably because, yeah, we were not at the right position. or we can add it manually. Another useful tool in case of challenging datasets where our arrivals are not clear is get guided by looking at the move out for a theoretical or user-defined position. So if we go to our 3D visualizer, perhaps here, and we select view, okay. So, yeah, we can insert a position for a theoretical event, an event that will be located where we think most of our seismic events will be located. So a reasonable position will be probably across, close to the injection point. In this case, it's at this level. So we can also adjust the position. So we can look at the properties and we can manually enter this position. So we can define this theoretical event and go back to our trace and show the move out, the overlay for an event that will be located at this position. You can see in pink will be the P wave arrival, in dark green will be the S wave arrival, and we can use this as a template across our trace, across our recordings, and see where would we find a match for this. And yeah, we can see that this move out is roughly similar to the arrivals that have been detected by InSite as the P wave and the S wave arrivals. In case there's more complexity in our traces and more challenging for auto picking, there are further settings that can be explored in InSite, and this is the optimise picking. If you have selected that option, you can go to the tab corresponding to optimise picking and configure the parameters used in this function. What this function does is basically it's a multi-step automatic picking. It will run a first auto picking as we've done now, and then it will fine-tune, it will refine this picking by using the arrivals, the first detected arrivals for all of our array, fit a curve that will fit well all our detected arrivals, and adjust outliers around the outliers in our picking around the curve that has been fitted to this to the best arrivals. So it works in a similar way as we've worked with the auto picking. Double window. It's just a re-picking window, so normally it's smaller, and it will try and look around the fitted curve. In this case, 20 sample points behind, 20 sample points ahead of it. We'll try and find a good arrival around our curve, our fitted curve. Okay, so this is it. I hope this was useful for you, and if you have any further questions, you can always get back to us at itasca@itasca.co.uk. Thank you very much.